Welcome students to today's session. In the last session, we finished images formed by a concave mirror, the ray diagrams for images formed by a concave mirror. This session we will start with image formation by a convex mirror. Now in convex mirror, we have two positions. One is rays coming from infinity, another one is rays in front of the mirror. When an object is at infinity, the image formed is at focus behind the mirror for a convex mirror. The rays of light strike the mirror and they get diverged because it is a diverging mirror, and we extend the diverged rays backward to the mirror and they all meet at a point called as focus. So image formed for an object at infinity is highly diminished, point-sized, virtual and direct. Since the image is formed at focus behind the mirror, the image is virtual and direct. So these are the qualities of the image formed. It is highly diminished, virtual and direct. We will go on to the next. Let us go into the next position. The object is placed in between infinity and pole. In other words, the object is placed in front of the mirror. The image formed. Let us look at the characteristics of image formed. The ray of light that strikes the mirror gets diverged. It can be extended to the focus behind the mirror. Let us take another ray which passes through center of curvature. The ray that passes through center of curvature reflects back in the same direction. Let us extend it backwards to see behind the mirror. We get an intersection behind the mirror, which will be the position of the image. The image is formed behind the mirror between P and F. The image is formed between P and F behind the mirror. Look at the quality of the image. It is an virtual and direct image. It is diminished in size. These are the qualities of the image. While drawing ray diagrams, please take the distance between P and F to be half of between P and C to get correct ray diagrams. Let us consolidate the position of images and the characteristic of images. At infinity, position of the images at F behind the mirror, highly diminished, virtual and direct. Between infinity and pole, the images between P and F behind the mirror, diminished, virtual and direct. Please remember this consolidation. Now let us look into the uses of concave mirror. Concave mirror is used in torches, searchlights, headlights of vehicles to get parallel beam of light. They are used as shaving mirrors to see large image of the face. They are used by dentists to see large image of the teeth. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. So these are the applications and uses of concave mirrors. Let us look into the uses of convex mirror. Convex mirror is used as rear view mirror in vehicles. The idea behind using a convex mirror is it gives erect and diminished image of the objects, and it can cover a wider field of view than the plane mirrors. So a large area behind the vehicle is covered inside the convex mirror. Hence they are used as the rear view mirrors. They are also used as magical mirrors to form funny images in many of the um, centers which you go for entertainment. So that is another application of convex mirrors. Both convex and concave is used in this. Let us now look into the new Cartesian sign convention for spherical mirrors. These are the conventional signs adopted to solve problems related to these concepts. Let us look into what are the rules to follow. The object is placed on the left of the mirror and light from the object falls onto the mirror from left to right. So this shows the first direction of the light onto the mirror. Whether it is a convex or concave mirror, the direction of incident light is always from left to right. All distances pertaining to the principal axis are measured from pole pole of the mirror. This is the pole of the mirror. So all distances pertaining to the mirror is measured from the pole of the mirror. So direction of light is from left to right. Distances are measured from the pole. All distances measured to the right of the pole is taken as positive. Distances towards the right is taken as positive. Distances towards the left is taken as negative. Keep this in mind always. All distances measured to the left is taken as negative. All distances measured to the right is taken as positive. So object is always in front of the mirror. So distance from pole to the object, that is u, is always positive, negative. Distance from the pole to the object is always negative. Image distance depends on the position of the object. Distances towards the left is negative, distances towards right is positive. Height measured in the upward direction, that is above the principal axis, is positive. Height measured below the principal axis is negative. So object is always upright, it will be positive. Images can be positive or negative depending on the position of the image. So height downwards is negative, height upwards is positive. These are the rules to be followed while solving problems related to mirrors, convex or concave. So let us look into the mirror formula. The mirror formula is 1 by V plus 1 by U is equal to 1 by F. In this, U is object distance, V is image distance, and F is focal length of the mirror. Magnification of the mirror. Magnification produced by the mirror is defined as ratio of size of the image to size of the object. Size of the image to size of the object. M is equal to H dash by H, where H dash stands for size of the image and H stands for size of the object. We can also write it as the ratio of image distance to object distance. So that will be with a negative sign. M is equal to H dash by H, that is ratio of size of the image to size of the object, which is equal to negative of V by U minus V by U. Magnification is also for a concave mirror and convex mirror minus V by U. H dash by H is equal to minus V by U. Please remember the formulas when solution of problems is asked for. Let us go into a problem. The problem is here. A convex mirror used for rear view on an automobile has a radius of curvature 3 meters. If a bus is located at 5 meters from this mirror, find the position, nature and size of the image. Now, when we get such a problem, the very first thing we will do is write down what and all data is given with the correct Cartesian sign in front of it. Radius of curvature R is equal to 3 meters. So F is equal to R by 2, which is equal to 1.5 meters. Now sign used here is positive because the mirror is convex mirror. We all know that focus of convex mirror is behind the mirror. and the measurement of distance is from pole towards right side of the mirror. So distances measured towards the right is always in positive. So F is plus 1.5 meters. Object distance U is minus 5 meters. That is the bus located. Always all objects are placed in front of the mirror. So the distance measured from pole towards left is minus 5 meters. Image distance we have to calculate, and height of the image h dash we have to calculate. So this is the mirror formula. 1 by V plus 1 by U is equal to 1 by F. We are supposed to find out image distance. So we have to first calculate what is 1 by V. We will rewrite the formula as 1 by V is equal to 1 by F minus 1 by U. Substituting, 1 by V is equal to 1 by 1.5 minus of 1 by minus 5. U is minus 5, and already there is a minus in the formula. Minus of 1 by minus 5, it becomes positive. So 1 by 1.5 plus 1 by 5. The value solution 1 by V is equal to 5 plus 1.5 by 7.5, which is equal to 6.5 divided by 7.5. This value is 1 by V. So we have to calculate what is V. V is equal to just the reciprocal of that, 7.5 divided by 6.5, which is equal to 1.15 meter. V is positive sign. That means the image is formed behind the mirror. It is not coming as negative. It is behind the mirror. It is a convex mirror. Now let us look into the magnification. Magnification is h dash by h, which is equal to minus v by u. We will use the formula minus v by 2 u. If height of the object is given, then we can use the formula h dash by h. Height of the object is not mentioned in the problem. So this minus 1.15 divided by minus 5. So magnification turns out to be positive. Both minuses will get cancelled. It becomes 0.23. So magnification is 0.23, which is a factor lesser than 1. So it's a diminished image. Image is virtually erect, smaller in size by factor 0.23. I will give you some clues. From the magnification, we can find out whether the object is magnified or diminished. The clues are here. Please note them down and remember them. If the magnification is lesser than 1, if the magnification is greater than 1, image is magnified than object. If the magnification is lesser than 1, image is diminished than object. If the magnification is equal to 1, image size is same as object. Negative magnification, then the image is real. Positive the magnification, the image is virtual. Height of the image is positive, then it is a virtual image. Height of the image is negative, then the image is a real image. So these points are to be remembered. When you solve problems, it will be useful for you. So that is the end of today's session. Please go through the problems of the textbook, which is given allotted work, complete it, and solve all the questions behind the textbook. Thank you.